All right, so today we're going to be talking about shaders. Big topic. I know there's a lot of anticipation building for lesson 2, shaders. In my own mind maybe, but anyway, the high-level idea that we're trying to learn today is how are the meshes that we worked with last time, how is that going to be turned into pixels? Because ultimately, anytime that you're drawing graphics on a screen, you're going to be using basically an array of pixels. And so we're going to be going from a three-dimensional context where we've got these positions that are represented as points in 3D space, and we're going to be turning those into points on a 2D space that's basically like a grid of pixels on your, let's say, laptop screen, right? So it's going to be two-dimensional space. We have to project this 3D space onto this 2D space and also turn it from this sort of point math data into pixels. So how does that happen? That's what we're going to be trying to cover today. So the basic idea is that we're going to be taking our mesh and putting it through what's called the graphics pipeline. Okay? And so this pipeline is a process of things that happen on the GPU, and we'll put this in like a black box, and it's this magical black box that converts our mesh into pixels, right? And so now what's happening inside of this graphics pipeline, because I mean that doesn't really explain anything. It's just saying, right, we're just adding something in the middle of here and then not saying anything about how this works. But basically, this is something that's happening on the GPU. And I should also mention, actually, before we break this down further, I should also, let's insert a step here, and let's say that we're going to have like a process that happens on the CPU that's called the renderer. And this is going to be like a component of the game engine that we're working inside of, that's happening on the CPU. And this is in charge of basically issuing commands to the GPU to tell it, okay, advance to this stage of the graphics pipeline, okay, advance. And it's going to kind of provide some of this information, like, for example, our mesh data is going to be fed through the renderer. And I said rendering, which, I mean, is correct, but I mean, I wanted it to say renderer. So this is like a component of the CPU game engine. And then this will submit things to the graphics pipeline, which then converts it to pixels. Okay, so now let's break down this graphics pipeline. And this is the part where we introduce the idea of shaders. And actually, before we dive into the multiple stages of the graphics pipeline, let's first explain a little bit on a high level what are shaders. They'll be used heavily in this graphics pipeline. So a shader is essentially just a program. A shader is basically, it's just a program. And it's typically like a pretty simple program, and I'll explain why. And it runs on the GPU. And what this shader is going to do, and this is what it's going to excel at, is it's going to do batch processing of data. So it's going to take like let's say an array of data, and we'll call this the input data. Let's add a little space between where it said pixel and input. Okay, so it's going to take this input data, and then it's going to feed it through this shader program on a element by element basis. And this is very important, right? Because it's not going to be looking at this entire structure, and at any point you can reference all the elements in this structure. It's going to be feeding these through individually on a batch parallel basis through this shader program that exists on the GPU. And then you're going to basically transform that input data into some kind of output data that's going to be different in some way than what you fed into it. Okay, so this is our output. And so you also may have heard this term SIMD, or single instruction multiple data. This is what the GPU excels at, is this parallel batch processing. Right? And you're going to get kind of like these arrows. I'm not going to draw all of them, but this is what the GPU excels at, and this is what's leveraged as part of this graphics pipeline in order to take your mesh and turn it into pixels. Okay, so the graphics pipeline now in more detail. now that we understand kind of a little bit about what's happening with the in a shader, we'll see how does our mesh get turned into pixels. So our mesh, the first thing that's going to happen to the mesh goes through the first stage, which is the vertex shader. And the vertex shader is going to be, as we mentioned, it's like a program that takes the vertex data that we authored as part of the mesh. And if you remember in the first lesson, we authored these points like 0, 0, 1, 1. And these points are in like the local space to that mesh. And we're going to transform that position from local space of the mesh into the ultimately the screen space of the device that we're rendering on. And so you can think of this in sort of multiple steps. I mean, this is like a default vertex shader. You can actually do a lot of stuff in this. This is actually going to be scriptable. So let's mark this as with a check. We can actually script this process, but I'll explain a little bit about what happens in like a typical vertex shader that just kind of works out of the box. Is that we're going to go from our like object space, local space of this mesh, we're going to transform that to like a global space. And let's see if we can get like a couple like countries here. That's pretty bad, but you can get the idea. There's the moon here. So this is like our global space. And let's move this over so I have a little bit more room to work with. We're then going to go from our global space, which is basically the space, the shared space of our entire scene. We then want to take that then back into a local space, this time of a camera, because we're going to be rendering this whole scene from a specific viewpoint. And so that's going to be the local camera space of our scene. And then, but this is still a three-dimensional space. We then need to transform that 3D space into our laptop screen array of pixels that we're going to be displaying here. And this is, again, this is a two-dimensional space. So we need to take this whole three-dimensional space into this two-dimensional space. And that's going to use projection generally, but in many cases it's going to be using perspective projection, which is like a special case of projection. And, you know, basically the idea there, and this is like a top-down view, is that we're going to take all these elements in a 3D space and they're going to be converged onto a single like plane here, which is called the picture plane. And that's going to be a specific kind of focal plane that the camera is going to capture. And that plane will then basically translate to what is rendered on this screen here. Okay, so this whole operation typically will happen in the vertex shader, though as we'll see in this lesson, you can do a lot of other stuff in this vertex shader. We'll do a very simple version in this lesson. So from the vertex shader, what we then go into is something called rasterization. If you have used like Photoshop at all, or Illustrator or that type of thing, you may be familiar with this term. In Photoshop, you would take like a smart object, which is vector data, and you'd convert that into pixel data. And so that's what this stage of the graphics pipeline does. This part is not actually scriptable. This is kind of like a fixed function that the graphics pipeline has. And it's basically going to take all of our points along with the triangle indices that we provided, that we set up last time. And it's going to basically figure out which pixels that those triangles are located in, which pixels that those triangles cover. And it's going to convert that into a set of pixel coordinates. And so pixel coordinates, not pixels. And like, what's the difference there? Because ultimately, then we're going to go in here to our pixel shader. And here we are scriptable again. And this is another program that's going to convert those like coordinates into like essentially colors. So this is how we say, okay, this is the color that you use to color this in, which before was just kind of like a coordinate to say, okay, there will be a pixel here. And so now that we have kind of an understanding of what happens in the graphics pipeline, let's hop back into Unity and start messing around with the mesh that we made last time and see if we can make anything cool happen with it in a shader. Okay, so we're back in Unity, and you'll see that we are kind of where we left off last time in Unity. We've got our faces that are pointing in the direction of the forward vector because we flipped the winding order. So what we want to do now is start messing around with our own shader. And so we made this unlit material last time, but what we want to do now is try to create our own shader. So let's go in here. First, let's create a folder for it. And let's then create a shader. And we're going to use this URP unlit shader. And so this unlit shader template will kind of give us the level of existing features that we're kind of looking for. We're not really looking for many existing features to be part of this. So let's call this the PFX shader test, okay, for procedural FX. And so we got our shader, and then now let's make, like, before we even do anything with this, let's change this to our PFX shader mat, and let's change the shader on this. It will be in here, custom PFX shader test. Okay, great. And so you can see right now it comes with this base color and base map, and our base color is white. So nothing really changed. We can come in here and change this. But for now, it seems like it's the exact same thing as what we had before we made this new shader. So let's dive in and see how that's actually being done. Let's look at this shader code. Before we start changing this, let's just take a sort of survey of how this is set up. So we've got this properties block. This is kind of a Unity custom thing. And you can see this kind of corresponds to what we saw in that inspector there. They're setting up a color and they're setting up a texture. And these are all things that you can go into the inspector and change. And those get propagated down into the actual shader code. You can see here it says HLSL program. That means the shader code is actually starting. And so those properties get propagated down from that block up there down here into the actual shader code in this location. So if we go to our cheat sheet here, we can see here are the stages that we outlined as far as the parts that are scriptable. We've got our vertex shader and pixel shader. So that corresponds to these two lines. Now they call it a fragment shader. You'll hear that a lot as well. I call it a pixel shader. I think it's roughly the same thing. There may be a technical difference, but think of them as the same thing. And so what this line is doing, this is kind of some Unity shorthand. This is basically saying the thing that's going to be providing the vertex shader is a function. Remember, it's like a program. And here it's like a function that's called vert. And then this fragment shader will be provided by a function called frag. So if we scroll down, we can see here's vert and here's frag. And you can see here's the return type of vert is this thing called varyings. And then in the frag, here's this return type called half-4. And this is basically like a vector. It's half precision, but it's color, right? So as I said before, the pixel shader is going to be outputting a color. And that's what this frag is outputting here is this in the form of a vector for a color. And it's going to take this varyings as an input. So it's going to, the output of the vertex shader, they call it varyings. I don't think that's a very descriptive term, but that's what they call it by default. You can come in and change all this stuff if you want. So we could go in and say varyings. Let's change this to, like I already have this in here actually, right? I can change that to fragment shader input. And then this attributes, which is the input structure type for the vertex shader, we can change this name to vertex shader input. So that maybe makes it a little bit more readable. It doesn't really matter what you call these things in your code so long as it's consistent. The thing that really matters as far as what the graphics pipeline is concerned with are these things called semantics. So this tells it actually what, when something is sent from the renderer to the graphics pipeline, right? It's going to be tagging it with these semantics and say, okay, this data has this position semantic. This data has a texture coordinate. This is the screen position, which we talked about a little bit here. So that's what this semantic means. And so those are the ones that really matter. We can go in and change these variable names. And again, so long as they're consistent, our code will compile. Now, if we look at this vertex shader, you can see here we've declared our fragment shader input here, and that's going to be the output from our vertex shader. And remember, it does get passed through this rasterization phase first, but then we do get, for each pixel, we get sort of this data output from the vertex shader for it's corresponding to a specific vertex. And it's actually going to be kind of interpolated between multiple vertices because it's going to be inside of a triangle. So that's kind of what this is going to be by the time it gets into the fragment shader. Okay, so you can see here where it's setting this screen position is they're calling it position HCS. So not sure exactly what that HCS, it says H clip, so I think this is H clip space, and the clip space is kind of another name for this pixel space here. And you can see they're doing it all in this one function. They're collapsing this whole set of functions where we go from object space to world space to camera space to, right? They're doing it all within this one function, which is a built-in Unity shader code function. You can pull all this stuff up online. I'm actually going to, in the video description, include some links to some built-in, not only HLSL built-in functions, but also some built-in Unity stuff, which is what this is. Because as you're learning this is a new language. It's going to be similar to what you've seen before, but it's a new language. So as you're learning that, it's useful to see what the built-in things you have available to you are. I mean, the good news is that it's a simpler language than C#, for example. Okay, and then it's also setting this texture coordinate, and then basically we're taking what we got in here, we're sampling a texture map, which is that map we declared here, and then we're going to multiply in our base color. We're going to get that as our color, and then we're going to return it, and then this is what actually gets drawn to the screen. Okay, so that's our basic, and let's just make sure that none of those changes we made, yeah, it doesn't look like those are affecting, they didn't break the compilation of the shader. So let's go in here and actually let's see if we just add a texture to this. Let's see what happens here. So if I add this, okay, I saw that the color changed a little bit, but I'm not actually seeing this like checkerboard pattern showing up. So maybe I just need to increase the tiling. Okay, so I mean I saw the tiling increased in this like test mesh here, but I didn't see anything on the mesh that we made. So why is that? If we go back to the shader code, let's make sure I have the right window highlighted there. So if we go back to the shader code, we'll see that what it's using to sample that map is going to be our UV coordinates. Well, hold on, we didn't actually define UV texture coordinates on our mesh. Okay, if we go back to where we declared on mesh, we set vertices, which is going to be like the vertex buffer, and we declared triangles. Now, if we wanted to add UV texture coordinates, what we could do, they don't call it that yet, they call it UV. So we could assign these vector 2s, and we could do something similar. But actually, instead of doing that, which we could do, instead of doing that, why don't we just send in our actual object space, is what they call it here, right? Our actual mesh positions, because we set this up where it's starting at 0, 0, and it's going to end at 1, 1. Well, those are great texture coordinates to use for this quad. So why don't we just feed in our model space positions basically as our UV texture coordinate? That way we don't have to add any extra data to the mesh, and we get the same functionality. So we'll say output.uv equals transform text. This is what's doing this tiling and offset here, is this transform text function. So let's keep that for now, and we'll just throw in the object space position, and we'll use XY because that's kind of what contains the actual data for our mesh. And so let's now see, and oh, look at that. We've got our checkerboard rendering on our mesh now. Okay, so we've actually now created our own vertex shader, right? So that's pretty simple, that operation, what we did now. So now let's start messing with the fragment shader or the pixel shader. And so actually, rather than doing stuff with these parameters that they've set up here, let's just delete that out and let's start manually changing this and manually setting what that output pixel is going to be. And actually, before we start changing the fragment shader, let's just look at this, rather than looking at it in the scene view, let's start looking at it in the game view. So let's jump over to the game view. We can see, oh, we're not seeing anything. That's actually because of what I was saying at the end of the last lesson, is that I kind of liked the winding order the other way because it would be facing the camera by default. I mean, I didn't actually mention that, but that's the reason why I like that. So let's just go in here, change the winding order back. Okay, we changed the winding order back. Let me change my key layout. I have to constantly toggle between Colmac and QWERTY. Sometimes I regret switching my text layout to Colmac, but okay, let's wait for this to compile. This is an awfully long compilation here. Okay, so now we're compiled. Let's rebuild this, and we can see, okay, here's the mesh. But wait, hold on. Why is it sort of off center like that? The reason, because my camera's centered, and then this thing is centered. The reason is because, remember, we put the lower left corner at the origin. And so this is going to be going off in the positive Y and positive X direction. So it's not centered correctly, but that's okay. We're looking at this in the camera, which is the important thing, because we want to just see how that transformation to camera space of the picture plane is working, right? Which we don't necessarily see in the scene view. So come back to the game view. Okay, so now we see that. Let's now start scripting this color output directly. And you can see I didn't save this. This is why I'm still seeing that checkerboard. If I save this, I don't think that's going to compile, right? So you get this pink color when it's not compiling. And you'll see here it says not all control paths return a value. So that's saying we've got a compilation error. We've got a compilation error in our shader. So let's fix that. Let's just return something that's half 4. Let's return red. And let's just see, this should be red, green, blue, and then this is alpha. So this should be red. Okay, there we go. We got red. So that's a very simple fragment shader, pixel shader. We got that going. So now let's say we still have this UV coordinate that's coming through. And so let's see what happens if we can get something that goes from red on the left side to green on the right side. And I think that should go through yellow. So let's see if we can get that. So what we'll say is we can say half 4. We could also use float 4s, but we'll say red equals this. And then we'll say green equals, in the second slot there, we'll put the 1. So that'll be green. And then what we can do is we can return lerp red green in.uv.x. So we'll use this uv.x coordinate, which goes from 0 to 1, and we'll use that to linearly interpolate between red and green. And this is, again, one of the built-in functions of, this time, HLSL, the language itself. So let's come back here, and we can see, okay, that didn't quite work the way I was thinking it would, because, so why is that? Okay, I think actually the reason is that we still have this transform text thing here. And if we go to our material, we'll see this has like a tiling still on it. So if we reduce this tiling, we'll see this is doing kind of more like what I thought it was going to do, which is kind of go from red to green smoothly and end at green, because we want this to kind of be this value that ends at 1. So it was going beyond 1 before, which is because we had this tiling enabled. So actually, for this experiment, let's get rid of that tiling now, right? I'll just delete it out. Let's get rid of that tiling, and we'll see now, even if we change this tiling here, right, it's going to have no effect now because we removed that. So, okay, we've got this thing that's interpolating between red and green. So what we can also do is, rather than linearly interpolating here, we could just return this this way. We could say, put the x coordinate directly into the red channel. Actually, we want to do 1 minus that because we want to start at red, and then as we go and increase this x coordinate, we want to reduce the amount of red to 0. And then here would be the x coordinate directly in the red channel. We start at 0 in the green and go all the way up to 1 in green. And let's see, that should be exactly the same, which it is. Okay, great. And then we could also do something where we're doing something with the y coordinate, because we've got this unused blue here. So why don't we do that? Why don't we say, put the blue in there. And okay, now we've got something that we're fully using these texture coordinates that we set up. That's just part of our vertex data. And okay, so now we've got this weird like off-center square, like what's going on with that? If we wanted to center it, we could do something like move this to like negative 0.5 and negative 0.5, because that would be the center of this object. And we've kind of moved that, or we could move the camera or something. But then we've got to, if we wanted it to fill this screen, we would have to do something like scaling it. But then the problem with that is, what if we wanted to change this aspect ratio? Like right now it's 16:9. What if we wanted to go to like portrait mode? So if we just scaled this object, it would no longer be full screen, right? So, or we start moving it around. So let's go back to this and let's zero this back out. I hit undo by accident. And let's try to see if we can change this vertex shader so that we're directly just going and filling the screen kind of no matter where this thing is positioned. Okay, so if we look at this thing here, as I said before, this is where the screen space is. If we just do this directly, what happens here? Okay, it doesn't like that because it needs a float 4 coordinate. So what you want to do with this is what we actually want to do is something like this, because we want this, when you give the screen space Z coordinate, which is what this is here, that's going to correspond to between the far and near clip planes of the camera. And so we want to just give it some value between 0 and 1 here. This thing, if you're going to be manually specifying the screen space, just always give it 1. It's going to divide by that value. And it's used elsewhere for the projection, like I was mentioning before. But just if you're going to be manually specifying it, use 1. So look over here. Okay, it disappeared. What happened there? Okay, so what we actually want to do is we want to actually go back into our mesh and again reverse the winding order to the way we had it at the beginning of this lesson, because right now our mesh is facing away from the camera. So let's go back here, and we're going back and forth vacillating here, but okay, so we've got something here. It's still off center though. Why is that? And this would be our last step here, is that this position, this screen space thing here that you can see, again, this is starting at 0, and we can see here that 0 is the center of this screen space coordinate. And so it goes from 0 to 1. And actually, if you notice, 0 to 1, so 1's going to be the bottom of this screen space coordinate. So that's just something to pay attention to. You remember we had blue be at where y is 1. And so this is going to be flipped in the screen space. The y coordinate is going to be flipped from what we're used to, where y goes up. Okay, so let's take this and we'll use like a screen space variable. So we'll call this screen pause. And let's go here. We'll make this a float 4 anyway. And for this part, we'll start with just saying that, and then we'll say screen position dot xy times equals 2, because we want to take this from going from 0 to 1 to something that goes from -1 to 1, which means it's kind of twice as large of a range. So we want to multiply that by 2, and then this is now going from 0 to 2, right? And so now we want to subtract out 1, and that will give us a range from -1 to 1. And so then now what we want to do is fill in this z coordinate like that, and we can say w is the final coordinate, and we can set that to 1. Okay, so now let's set that. And okay, great, except now we still have this reversed thing where this blue is at the bottom, which we don't want to do. So before we do this transformation, what we could do is just say screen pause.y equals 1 minus screen pause.y, and that didn't seem to like that. Okay, so because again, we're messing with the order and things like that. So the winding order, let's see if this works. Screen pause.y times equals -1. Again, we have the same problem. So now we go back again, and let's change the winding order. Let's go back and change the winding order once again. And let's regenerate our mesh. And there, okay, now we've got something that, and let's go full screen on this thing. So now we've got something that's fully filling the camera. And so you can see we had to kind of struggle through certain snags, kind of go back and forth, mess around with things. And that's going to be normal. That's going to be part of the process here. But the great thing is now we can go to these different aspect ratios, and this is all going to be matching exactly with whatever aspect ratio that we want to see here. So hopefully you got something out of this, and this is like, again, really basic, simple stuff, but we've basically learned how a mesh works in code, how shaders work, and now we can start building on that and start making things that look a little bit cooler and look a little bit more like what you would expect to see in a game. So that's what we're going to do in our next lesson. We're going to start modeling things that would actually be 3D objects you could put into a scene. Okay, so see you in lesson 3.